Hey there, everyone. Mrs. Bloor. Today, we started our quadratic unit today, Unit 2, and we started talking about standard form versus vertex form. And where we had left off in class was we had started talking about the parent function and what it looks like versus a typical function that you'd see in vertex form. So here is my parent function. When we talked about this in class, we talked about it being concave up. So that is the term that we use, is concave up. It means that the parabola itself is shaped right side up. And then we also talked about the vertex. The vertex is HK, which is 0, 0. So you have this parent function. It's the most basic function of all the quadratics. And in standard form, the way that looks is f of x equals 1x squared plus 0x plus 0. So really just a fancy way for saying f of x equals x squared. So that's your most basic quadratic function. Now the nice thing is, standard form doesn't really give us much information except for like if it's flipped up or down. If it's reflected, that would be the a value that's given to us. That would tell us that. But in vertex form, we have a lot more information. So here's the cool thing. The parent function in vertex form looks very similar here to that. And here's the reason why, right? If we were to simplify this whole thing, we'd end up getting the same thing that we got in standard form. Okay? But vertex form actually gives us some really good pieces of information. It tells us what the vertex is. Remember, the vertex is HK. And it also tells us whether or not it flips up or flips down. So is it concave up or concave down? So let's actually take a look at another example. So this is the one that you're going to sketch into your notebook. Okay. Y equals 2x squared minus 3. So take a moment, jot down some things that you know about this function compared to the parent function. What are some things that you know about it? So hopefully you jotted down a couple things like it stretches because it has a coefficient of 2. So we know it's going to stretch. It's going to get more narrow. We also know it's going to shift vertically down 3. So if you know those things, and you know what the parent function looks like, we can probably graph this pretty quickly. So we know it's shifting down 3. 1, 2, 3. So my vertex is now going to be there. Right here. And instead of going up 1 over 1 for our first unit, we're going to go up 2 over 1 because it has a coefficient of 2. So 2, 4 would have been much higher. So it's going to be stretched out like this. Okay. Again, the parent function, hopefully you knew and remembered that you have 0, 0, 1, 1, negative 1, 1, negative 2, 4, 2, 4. So that's where I'm getting those numbers from. Okay. So here's our actual function itself. And so in standard form, we actually know what this equation is. It's y, or f of x, equals 2x squared plus 0x minus 3. Again, the really only important piece of information that we have there are our 2, which tells us it stretches, and our negative 3, which tells us that it shifts down 3. But the nice part is, vertex form, we could write it this way pretty easily as well. We know what the a value is. It's 2. Okay? So we have f of x equals 2. We have our x. Now what we need is our h and our k, our vertex itself. So let's take a look at our vertex. It was 0, negative 3. So x minus 0 squared plus 3. This should look familiar to the original function. So look at the original, 2x squared minus 3. Now this looks just like it, but instead we have our vertex in there as well. So vertex form is really handy if you want to graph it pretty easily, looking at the shift horizontally or vertically, the shift vertically here, the shift horizontally here, and then also the stretch right here. Okay, we're going to look at another example tomorrow to start the class off, and we'll start talking a little bit more about the concave up versus concave down. If you want to do a little bit more research on that before you come in, that would be great, but it's not required. Okay, I'll see you tomorrow. Have a great rest of the day.